Hi SQL folks, welcome to another tutorial from SQL Maestros. Today I will show you the mechanisms involved when the optimizer has to make a decision about selecting an index and whether to scan or seek on that index. Now in past I have shown a lot of demos on this channel and on sqlmaestros.com and in our webinars where we use these terms like sargability, predicates, leading column in the multi-column index and whatnot. But today I will keep it very simple and just show you a couple of examples of, let's say, bad T-SQL versus good T-SQL, and just clearly try to explain you in simple terms as to when the optimizer is choosing an index and how does it decide whether to scan or seek on that index. Now, a part of the optimizer when it has to deal with indexes is to choose the right index out of all the available options and whether to scan and or seek on that index, which is like the access method, and whether to do a bookmark lookup depending on the attributes that you want in the query. How many columns are you trying to extract? So I mean, can covering index be an option? Does your index cover the query? A lot of decisions are made, and then those decisions get complicated if it has to deal with single column and multi-column indexes. A lot also depends on the expressions that you are using in your T-SQL. Now, all the decisions that the optimizer takes are cost-based decision, and today during the demo in this video, I will try to show you the cost factor also a bit. Now, what optimizer really wants to do, and you would also love that the optimizer does, is seek on the index. That's kind of the primary requirement, the main objective when you create an index. Index is a B-tree structure, and you would want that the optimizer seeks on that B-tree structure, which is traversing from root to intermediate level and to the leaf level, pinpoint exactly the data that your query wants, the data that the optimizer is trying to seek. Now, in most cases, what you don't want is you have the right index in place, but the optimizer is not able to seek on that index. Instead, it lands up scanning. This is what you want to avoid. And despite a lot of learnings that we have imparted on this channel and from all the different sources, I keep seeing those bad T-SQL predicates that will prevent the optimizer from seeking on that index. So I thought in today's video, why not just simply put up some examples to show you that why the optimizer is not able to seek, and when it is able to seek, so the good versus bad, so that you just have a very clear idea about the kind of T-SQL you would want to write. Okay, so let's get started. And I've broken this up into two parts, which is dealing with single column indexes and multi-column indexes. The single column index demonstration is being done now in this video that you're watching, which is freely available to everyone, publicly available to everyone. The advanced part of this demonstration, which is dealing with multi-column indexes, that becomes a little complex. That is available in our members only list on the YouTube channel, and it is available as part of premium membership on sqlmaestros.com. More on that later, but let's first get started with the content. So we're talking about index selection by the optimizer. First, we are going to deal with single column indexes. Let's check the data. We are playing with person.person, and I will be just playing with two attributes here, which is the last name and the first name. This is one of the tables in AdventureWorks database. This demonstration will work good with different versions of AdventureWorks, 2016, 14, 12, and whatnot. Okay, now let's first review all the indexes that are available in this table, on this table, person.person. And let's see what we have. There you go. So we have a couple of indexes. Let's just focus on the one that we are going to use in the demos today. So we have an index on last name. So if you can see, this is a single column index, just a non-clustered index on last name. And this is a non-clustered index, and you can see the index keys as last name. SP help index does not show you the columns that probably could be in the include keyword. So it does not show you that. Probably you're aware of that. And even if you're not aware of that, keep that in mind. So I would say SP help index as a system stored procedure is kind of incomplete because it does not give you the full details. So, but you can trust me and I can tell you that this is a single column index on last name and it does not include any other attribute in the include keyword for the purpose of covering. Then we have another index which is a multi-column index. This is on last name, first name and middle name. This is the order of columns in this multi-column index, which is visible here from the index keys, last name, first name and middle name. In this demonstration, I'm not using last name, first name and middle name index. I'm only going to play around with this one. The advanced part, the complex part dealing with multi-column indexes is covered up in the advanced demo. Okay, now let's get started. Here are three examples, three queries which are the good ones. These are the ones that you would want to write. These are the queries that the optimizer will love because it will allow the optimizer to seek on the index. But before we talk about seeking, what really is seeking? In a single column index or even in a multi-column index, let's just focus on the first attribute. In a single column index, there will be only one attribute as part of the index key. So when the optimizer is trying to seek, it wants to search exactly on that value, on that index key value. If it is able to do that, it will be able to perform a seek operation and traverse the B tree structure. So let's take the first query. Select last name from person.person where last name is equal to Miller. Now you are using a couple of these predicates like equality operators and non-equality operators. This will allow the optimizer to seek exactly on that index key. So if I select this and execute and jump over to the execution plan, you will see a perfect index seek operation. This is what you want. So equality operator in your predicates, thumbs up. Now let's use a non-equality predicate here. So we say last name less than Miller. I know this may not make sense, but just to show you, this could be a numeric attribute as well. So less than, greater than, less than equal to, greater than equal to, not equal to, all that is pretty good. So let's go and run something like this. And will the optimizer love this? Yes, it does. So you have an index seek happening. You can see on last name, and this is an index seek operation. All good there. Let's try something like this where last name like Miller. This is an interesting case because sometimes when I ask people, will the optimizer seek on this one or will it scan? I get kind of distributed response. Some people say it's going to seek. Some people say it's going to scan. Why? Because you have a wildcard here and you have the like operator. So you kind of start thinking, will there be exact match searches here? This is not going to be an exact match search, but neither is this ever an exact match search. Only this one is. So let's see what happens. And then we'll try to demystify this a little more. So like Miller, and then you have the wildcard. Let's go and execute this and jump over to the execution plan. And yes, this is also a thumbs up, which is the optimizer is able to seek on the last name index. And rightly so, because the wildcard is at the end of your predicate, of your search criteria here. So in your leading column, which is last name, you have a good starting point. So you can start seeking from there. So this is all good. But what is not good? Yes, if you just make a small change to this, this will change the story completely. We will do that right now in a moment. Okay, so these were the good examples, the kind of queries, the kind of search predicates you would want to write. That is why we use this term sargability, right? Search argument ability. But as I promised, I'm not going to use all those terms today, but these are all sargable queries, sargable predicates, all good. What is not good? The bad versions, right? Which will force the optimizer to scan instead of seeking on the index. And this is what you want to avoid. Something like this, where you use a T-SQL function on the attribute on which there is an index, which means last name is the index key, and you use a T-SQL function here on the left hand side of the operator. This will prevent the optimizer from seeking on the index. Instead, it will land up scanning. So if you say ltrim, rtrim, or upper or lower, whatever T-SQL functions, and when you use numeric attributes like ABS and whatnot, this will prevent the optimizer from seeking. So if you do something like this, let's go and execute this, even though you have an equality operator. That's the point to note. Jump over to the execution plan and you see a scan. Bad, right? Typically, when you're dealing with a lot of numeric attributes, you do something like this, which is on the left-hand side of the operator, you're trying to do a lot of mathematics, which is what you should avoid. Because again, if you're trying to operate on the attribute, which is also the index key, on the left-hand side of the operator, this will be bad for the optimizer. Again, something like this, not acceptable. And again, seeking will be lost. Let's go to execution plan and you will see not good. This is again scanning. What else? This was the tricky one. So if you see this is what we had earlier, isn't it? This was seeking. So I'm just trying to do a quick recap. This is seekable, what we saw earlier, all good. But the moment you move the wildcard character here, then this will lose the seeking capability. Why? Because you don't know the searching, the start point. If you don't know the starting point, optimizer will have no way to seek, and which means touch all the data of the index and land up scanning. You need to avoid things like this. Jump over to the execution plan and you will again see a scan. Alright, so what you have learned here is the mechanisms involved in the optimizer choosing the right index. We didn't talk much about choosing the right index because we were only playing with one attribute, which is last name, and the optimizer got a very good index, a single column index on last name, and last name was the only attribute that you wanted in your select list, and this was the only attribute in your predicate. So all was good in terms of choosing the index, but then you saw when is the optimizer able to seek, which are these examples, and seek these examples when it is able to seek, and when it is not able to seek. So with these examples, just keep in mind the kind of T-SQL you would like to write. Hope this was useful. Now, the part 2 of this, which is the advanced version, which is where I discuss multi-column indexes and the complex expression treatment. Now we take multiple attributes and multi-column indexes. If you want to watch that, you can become a member on our YouTube channel. That's in the members only list, and a lot of advanced content out there, including paid webinars. Or a better option is you can jump over to sqlmaestros.com and you can take a premium membership where you will get access to all our advanced tutorials, all our paid webinars as part of your annual premium membership. Alright friends, and if you want deep dive into SQL Server performance tuning, the masterclass recordings, 40 hours of deep dive content is now available on sqlmaestros.com. 60% discount and lifetime access. Yes, watch anytime, anywhere, as many times as you want. All of this is available on sqlmaestros.com. If you like this content, today's demo, today's tutorial, do share it with your friends and colleagues and put down a comment on this video that what have you learned? Did you know about these things? And what would you like me to cover in the upcoming videos? This will be a good way to interact with you. So let's start talking in the comments section. Happy SQL. If you like the content, give it a thumbs up. Subscribe to the channel and click on the bell icon so that you're notified on new videos. Most importantly, visit sqlmaestros.com. There's a lot of SQL learning resources out there: video courses, master classes, lab kits, ebooks, blogs, hands-on labs, and a lot more. Follow us on Twitter @SQLMaestros and myself _Bansal. Last but not the least, do subscribe to our newsletters. See you soon in another video. Goodbye.